Okay, today we're going to do now section 1.2. I'm going to do some of the problems from page 15. The first two problems ask you to graph the numbers on a number line. So I start with a number line. I'm going to put both numbers on the same line. The very first thing you should do is mark 0. Okay. And since these numbers are not very big, I'm going to be able to actually mark 1, 2, 3, 4, and I'm going to go down, -1, -2, -3, and so on. Make sure your number line, the numbers are in the right order. Okay, now that might sound simple, but sometimes people get a little mixed up with the negatives. As the numbers get smaller, 4, 3, 2, 1, 0, then it's like 1 down, 2 down, 3 down. It keeps getting smaller. So if you think of if you were going maybe down in an elevator, right? As you go down, the floors would progress like so. Maybe this is like 1 story underground, 2 stories underground, 3 stories. That minus is how far down. Okay, so that might help you for those of you who might sometimes forget which way the numbers go. Okay, so 3.5. Well, 3.5 is 3 5/10, or 3 1/2. So it's halfway between 3 and 4 right here. 3.5. -1.4, well, that's with the negatives, and -1.4 is smaller than -1, but bigger than -2. So it's almost halfway, but a little closer to -1. Okay, so you could also use this as an example to help you remember where numbers go on a number line. Okay, the next thing we're going to do is figure out which number is greater than, less than the other. Okay, so we start with 23. We have 16 and the square root of 16. And some of you, after a long summer, might have said, I forget what that means. So what I like to do is have, and you can have some notes in your notebook, things that help you remember how to do something. So in this example, what I would use is the square root of 25, just because there's something special about this number. The square root of 25 is equal to 5. And that means that 5 times 5, or 5 squared, is 25. So squared, square root, they are inverses. Square root, square. One undoes the other. That's what an inverse does. Okay, so you might keep this in your notebook, and so whenever you see a square root, you know what to do. Okay, so let's do the same thing here. The square root of 16, what number times itself is 16? That's 4. And 16 is definitely bigger than 4. So I put a greater than sign right here. 16 is greater than square root of 16. Okay? It's also called, if you learned this last year, let me just put it up here, square root of 25 is also read radical 25. Okay, so you might have learned that last year. Okay, next we have 4 and the square root of 12. Well, we already know that the square root of 16 is 4. So the square root of 12 must be smaller. So 4 is greater than the square root of 12. Now you could calculate this using a calculator, but you really don't need to, because you know 4 times 4 is 16. So square root of 12 less than 4. Next we have -8 and the square root of 70. Do we have to even think about the square root of 70? all we have to say is this is positive, this is negative. Negative is less than positives, okay? -8 less than square root of 70. Square root of 75, how does that compare to 9? Well, what is 9 squared, right? I think the other way I say, well, 9 squared is 81, so that means the square root of 81 is 9. So the square root of 75 must be less than 9. One last thing I want to mention is some people get mixed up with their signs. You might know how to do the problem and then you have your sign turned around. So less than, you could say looks like an L. Maybe that would help you to figure things out. Or you could say that the smaller part of the sign points to the smaller number, the bigger part of the sign to the bigger number. So if I were to, so this must be 2 greater than 1, 1 less than 2, okay? So keeping examples, maybe you keep this. Maybe this is something you keep in your notebook to remember. Maybe this, less than, and you could write out greater than. And I think this idea is a great idea. I always used things like this to help me when I'd have a hard problem. Maybe you would have a square root that's very complicated and it confuses you because there's so many things going on, okay? Imagine you had the square root of something that looks like this. Well, as a matter of fact, let's do this. 25 a to the 4th, b to the 9th, you know, something like that, and we will see that a little later. And you might get mixed up because there's so much going on, okay? So having these basics is really important, okay?